Let's take a journey back in time about 2 billion years into Earth's evolution. This was a period teeming with life in some respects, yet also marked by a significant turning point. It was a time of flourishing microorganisms, but it was also when one of the most colossal extinction events in history occurred. This invisible menace, which had a profound impact on Earth's trajectory, set the stage for the modern world as we know it today. It altered the atmosphere, reshaped ecosystems, and influenced the development of future life forms. The animals we see today, the food we consume, and even the air we breathe all owe something to this transformative period. Imagine boarding a time machine and preparing for your descent to Earth 2 billion years ago. You're landing at a pivotal moment in history. Earth is about halfway through its current age. As you approach the surface, you'll notice that the planet looks very different from the Earth of today. Blobs of land, early primitive land masses, float separated by expansive oceans, maybe dotted with chunks of ice. These land masses bear little resemblance to the continents we know today, but that would soon begin to change as geological forces continue to shape them. When your time machine touches down, the environment you step into is a stark, barren landscape. It's a rocky, bleak scene with no trace of the lush greenery or teeming wildlife that defines modern Earth. There are no trees, no plants, no complex vegetation of any kind. You won't even find animals here. Life at this point existed only in its most basic form, microorganisms. This was a world before the rise of multicellular life, and the dominant forms of life were simple organisms like bacteria. As you stand in this ancient world, you might think it seems quiet, even dull by modern standards. But in some ways, this simplicity is a relief. At least there are no predators around. The lack of complex life means you don't have to worry about being hunted. However, before stepping out of your time machine, you'll need to put on a protective suit with an oxygen tank. While there is some oxygen in the atmosphere, it's far from sufficient for you to breathe comfortably. Oxygen levels are less than 10% of what they are today, so without protection, you wouldn't last long in this environment. When Earth first formed, its atmosphere was dominated by gases like carbon dioxide, methane, and water vapor, with little to no oxygen. Over time, the atmosphere gradually changed, driven in part by the actions of tiny organisms. As you step outside, you'll notice that the waters surrounding you are calm, almost eerily still. Don't expect to see fish or any familiar aquatic life. Instead, the water is teeming with something far more primordial, cyanobacteria, also known as blue-green algae. This slimy green bacteria is one of the most important life forms to have ever existed on Earth. Cyanobacteria are responsible for producing the oxygen that we rely on to survive today, but they were also the catalysts of the most devastating mass extinction event in Earth's history. To understand how this extinction unfolded, we need to go back even further in time, another 500 million years. As you make this second time jump, you'll find yourself in an Earth that is barely recognizable. This was an era when oxygen was virtually non-existent and the Earth looked far more alien than it does now. The sun was dimmer, and the young Earth had a far cooler climate, though still warm enough to sustain liquid water. Life during this period was confined to single-celled organisms, with bacteria being the dominant form of life. Cyanobacteria, in particular, played a crucial role in shaping Earth's atmosphere. They had evolved a unique ability to harness sunlight and use water to produce energy through photosynthesis, a process that released oxygen as a byproduct. As more and more cyanobacteria engaged in photosynthesis, they began to pump oxygen into the surrounding environment. Initially, much of the oxygen they produced reacted with minerals in the oceans and the crust, effectively removing it from the atmosphere. But over time, as cyanobacterial colonies grew and proliferated, the amount of oxygen they produced exceeded the capacity of these natural processes to absorb it. This oxygen began to accumulate in the atmosphere, marking a turning point in Earth's history, the Great Oxidation Event. At first, the presence of oxygen in the atmosphere didn't seem like a big deal. After all, life had existed without it for billions of years. However, for the other bacteria that had thrived in an anaerobic, oxygen-free environment, this new development was nothing short of catastrophic. Oxygen, which is essential for most modern life, was toxic to these early life forms. As the levels of oxygen in the atmosphere increased, it became increasingly difficult for these anaerobic organisms to survive. They began to die off in massive numbers, triggering what is now known as the First Great Extinction Event. This extinction wiped out 99% of all life on Earth at the time. But the consequences of the Great Oxidation Event didn't stop with the mass extinction of anaerobic life. The sudden influx of oxygen also had a dramatic impact on the planet's climate. Oxygen displaced the methane and carbon dioxide that had previously dominated the atmosphere. These gases had created a potent greenhouse effect, keeping Earth warm enough to support liquid water and life. With their removal, the planet's climate began to cool rapidly. This cooling effect eventually led to one of the earliest known ice ages, the Huronian glaciation. Over the next few 100 million years, Earth's surface would be transformed as ice sheets spread across the land and oceans froze. The Huronian glaciation was a prolonged and intense period of global cooling that covered much of the planet in ice. During this time, Earth went through 3 major glaciations, with ice covering not only the poles but also the continents and even reaching sea level in some places. It was a world of ice and cold, with much of the planet's surface locked in a frozen grip. Life on Earth, already reeling from the Great Oxidation Event, faced an even greater challenge. The Ice Age further reduced the habitable environment where life could survive. However, not all was lost. A small fraction of life, about 1% of the microorganisms that existed before the extinction, managed to cling to existence in isolated pockets of warmth. These survivors, though microscopic and sparse, would eventually give rise to the complex life forms that would one day populate the Earth. As you continue your journey through time, you'll see that Earth begins to warm again, thanks to a combination of factors. One of the most significant contributors to this warming was volcanic activity. Despite the ice covering much of Earth's surface, the planet's interior remained hot and active. Deep below the surface, the heat of Earth's molten core was driving powerful tectonic forces. This tectonic activity triggered widespread volcanic eruptions that released massive amounts of carbon dioxide and water vapor into the atmosphere. These gases acted as greenhouse agents, trapping heat and slowly melting the ice that had gripped the planet. In addition to the warming caused by volcanic activity, the sun itself was gradually growing brighter. Over time, the sun's luminosity increases, causing Earth to receive more solar energy. This process, though slow, contributed to the melting of the ice sheets and the eventual end of the Huronian glaciation. As the ice retreated, Earth's landscape was once again transformed. Volcanic eruptions not only helped to warm the planet but also played a role in shaping the continents. The small landmasses that existed during the earlier part of Earth's history began to merge, eventually forming Earth's first supercontinent, Nuna. As Nuna took shape, Earth was on the brink of a new era, one marked by the emergence of more complex life forms. The atmosphere, now enriched with oxygen, provided a foundation for new types of life to evolve. Cyanobacteria, once the architects of oxygen production, had laid the groundwork for the rise of aerobic organisms, those that could use oxygen to fuel their metabolisms. Over the next few 100 million years, these microorganisms would give rise to more complex multicellular life, setting the stage for the explosion of biodiversity that would eventually lead to the evolution of plants, animals, and ultimately, humans. One of the most remarkable aspects of this period in Earth's history was the development of Earth's protective ozone layer. The oxygen produced by cyanobacteria not only fueled new forms of life but also formed a layer of ozone high in the atmosphere. This ozone layer provided crucial protection from the sun's harmful ultraviolet radiation, allowing life to thrive on land as well as in the oceans. With the ozone layer in place, Earth's surface became more hospitable to life, paving the way for the eventual colonization of land by plants and animals. Thanks for watching.